Today we've been asked to find the maximum, the minimum, the phase shift, the period, and the frequency of each equation. We've been given three separate equations. The first equation is a low voltage AC circuit with X equal time in seconds and Y equal to the voltage of the circuit. Now, the maximum and the minimum for a sine function are going to occur at the peak and the valley. And the easiest way to find the maximum and the minimum for any sine function is to look at two things: the amplitude and the vertical shift. Now, for this particular equation, there is no vertical shift. So the maximum is simply going to be the amplitude. Okay? So the maximum for this equation is going to be 18. And since the y-axis is voltage, this would be in volts. Now, the minimum is very similar. The minimum for a sine or a cosine function also occurs at the amplitude, but instead of positive 18, it's going to be at negative 18. Okay? So negative 18 volts. The third thing we're asked to find is the phase shift. Now, we're told that X is time in seconds, and so what you want to look for is the horizontal shift. Where is the horizontal shift in this function? And it's right here. This is the horizontal shift right here. 0.015. And it's added. And what do we know about horizontal shifts? Horizontal shifts are always backwards. So what that means is my brain says to me, oh, it's plus 0.1015. That means it's to the right. It's always backwards. And so what does this mean? This means it's 0.015 seconds to the left. So the phase shift is 0.015 seconds, and it would be to the left, or it would be, a lot of times in electronics terms, you say this is lagging. It's moved to the left, so it's behind, it's slower. Okay? The last thing we're asked to find is the period and the frequency. Well, how do you find the period of any sine or cosine function? Well, the period of any sine or cosine function is 2 pi over b. So I put 2 pi over, and I look for b. And where is b? Right here. 120 pi. So 2 pi over 120 pi. And of course, pi over pi's cancel, and 2 over 120 is the same as 1 over 60. What this means, and the period is always going to be whatever the x-axis is measured in. So it's going to be in seconds. So the period of this function is 1 over 60 seconds. What that means is it takes 1/60th of a second to make one sine wave. Okay, that's what that means. Now, the last thing we're asked to find is the frequency. The frequency of a sine or a cosine function, there's two ways to find it. One is you can put b over 2 pi, or you can find the reciprocal of the period. If you put b over 2 pi, you're going to get 120 pi over 2 pi, or if you take the reciprocal of the period, well, what's the reciprocal of 1 over 60? It's just 60 over 1. And so the frequency of this particular function is 60 over 1. And since time is in seconds, frequency would be in cycles per second. So this would be in 60 cycles per second, or 60 hertz, which is what most of you would be familiar with if this is a problem you would be doing. Okay, so let's move on to problem 2. Problem 2 says y equals 120 sine 200 pi x minus 0.18 plus 20. And this is the equation for a high voltage signal transmitter. Time is still in seconds, and x is still time in seconds, and y is signal amplitude. Now, we're asked to find the maximum, the minimum, the phase shift. Okay, so let's start with the maximum. Well, if you look at this, this is the amplitude, and I'm going to mark these on this one in a different color here. This would be A, this is our amplitude. this would be B, this would be C, and this would be D. Okay, A, B, C, and D. And those come in quite handy, so we're going to use those. Now, the maximum is always going to be the amplitude plus any vertical shift. Well, in this case, it's shifted up 20. So normally this thing would have a maximum of 120, but since all points have been shifted up 20, you're going to take that 120 and add 20 more to it, and you're going to get a maximum of 140. Okay? How about the minimum? Well, the normal minimum would be negative 120. But all points have been shifted up 20. So what's negative 120 moved up 20, and it's negative 100. Okay, so the max is 140, the minimum is negative 100. The third thing, the phase shift, real simple thing to do here. Phase shift is always basically the horizontal shift. It's C. Now, phase shift is always backwards in the equation, so it's negative 0.18. That means it's moved to the right. So it's moved to the right 0.18. And since x is in seconds, this also has to be in seconds. Okay, so this means it has shifted 0.18 seconds to the right. Or a lot of times in electronics, you'd say that leads. So it's leading the standard signal by 0.18 seconds. Okay? We've also been asked to find the period. And the period for any sine or cosine function is always going to be 2 pi over b. And that's going to be 2 pi over 200 pi. The pi's cancel. And 2 over 200 is the same as 1 over 100. And that's also going to be in seconds. Periods measured in time for a function like this. So what does that mean? That means it takes 1/100th of a second to make one sine wave. It takes 1/100th of a second to make one sine wave. And the last thing we've been asked to find is the frequency. And the frequency is always going to be b over 2 pi, or it's going to be the reciprocal of the period. Well, if the period's 1 over 100, flip that and you get 100 over 1. So the frequency will be 100 cycles per second, or 100 hertz, which is again a more common unit for most of you. 100 hertz or 100 cycles per second. Okay? Number 3, we're given negative 51 cosine 0.017214 x minus 16 plus 23. This is the temperature model for Anchorage, Alaska. X is time in days, and that's important to remember here. X is time in days, and Y is temperature in Fahrenheit. Okay? And we're asked to find the same things, the max, the min. So what is the max? Well, the maximum is going to be the amplitude, 51, plus 23, because this entire function has shifted up 23 units. Okay. What is 51 plus 23? How about 74? And this would be in units of degrees Fahrenheit, because we're asking what is the highest point this reaches, which would be measured using the y-axis. Okay, the height of this thing would be used measuring the y-axis, and since y is measured in temperature, the maximum would have to be measured in temperature. How about the minimum? Well, the minimum for a cosine graph would normally just be the amplitude, 51. It'd be negative 51. But then we moved everything up 23 degrees. So what is negative 51 plus 23? That's going to give us negative 28 degrees F. Okay. Now, given that, we want to find our phase shift. Phase shift. And phase shift for any graph is always just going to be the C term, okay? And again, if I labeled these, this would be A, this would be B, this would be C, and this would be D, okay? And the C term for this would be negative 16. Only this time, you have to pay attention. Time is in days. So X is in days. If this is in days, this also has to be in days. So this is 16 days, and it's negative. So it's minus 16. So this is going to be 16 days to the right, or 16-day lead. It's going to be a 16-day lead. Okay? What does that mean? Well, that means if this normally starts on January 1st, you're going to move 16 days ahead in the calendar, which means now this graph is going to start on January 17th, 16 days ahead of where it would normally start. Okay? And then we're asked for the period and the frequency. And the period is going to be 2 pi over b. Okay. So we say, all right, well, you've got 2 pi and you've got b. B is a small decimal, so it's 2 pi divided by 0.1017214. And when I do that division, I come up with roughly 365 days. What does that mean? That means it takes 365 days to make one cosine wave. Okay? Now the frequency. What's the frequency? Well, frequency is take the period and flip it. How often does this wave repeat? And the answer is 1 over 365 cycles per day. Okay? Now normally we say cycles per second because the time is measured in seconds. Notice here the frequency is cycles per day because time is measured in days. Okay? If you have any questions, please let me know.